The Hawkesbury River and its tributaries form a part of a semi-mature drowned valley estuary. Due to its volume and extreme tidal influence, it transports masses of sediment and is constantly transforming. It can be divided into two main facies: an outer marine-dominated zone that is characterized by a large sand flood tidal delta, and a river-dominated zone characterized by a progradational bayhead delta. The interaction it has with its geological composition, weathering, tidal movement, fluvial processes, and the human interactions has allowed for the shaping of the Hawkesbury River and the landforms that surround it. These landforms are predominantly dominated by a top layer of Hawkesbury sandstone, a sedimentary quartzose sandstone, making it susceptible to erosion. Due to its large amount of distributary channels and sedimentary sources, the system accounts for substantial fluvial deposits, especially during time of extreme weather, flood, and major runoff events. The sediment is deposited at the river mouth and often distributed to surrounding beaches. This is determined by the presence of estuary subaqueous fluvial sands overlying marine sands at the mouth of the river system.
Bondi Beach is a rhythmic bar and beach formation in the eastern suburbs of Sydney renowned for its ideal surf conditions. Bondi's cliffside formations are comprised of Hawkesbury sandstone from the late Triassic period, while its sand is primarily composed of quartz and shells. Boundary headlands formed by erosion create a south-southeast swell on the southern break and an east-east-south swell on the north, generally made of 3 to 4 wave sets. This wave action amasses in the middle, creating a central rip current. Surf swell begins as collected sea winds that form a rotational forward movement that compresses and gains shape as a wave when traveling over a shallow sandbank. The intensity of this swell is governed by the gravitational pull of the sun and moon. Back and forth tidal movement erodes and deposits sandbars, meaning the surf break can be relocated after a heavy tide or storm.
Different types of sands. Let's now touch on mineral sands. Mineral sands are sands that contain minerals such as rutile, ilmenite, zircon, monazite, and magnetite. Some mineral sands, such as the volcanic sands, are formed due to the volcanic activity taking place in Antarctica thousands of years ago, which have migrated to the Australian shores. Mineral sands are economically and technologically very important due to their mineral composition. For example, titanium-bearing minerals are used in the manufacture of titanium dioxide pigment. Zircon is being used in the manufacture of ceramics and refractories. Mineral sands can be found across all Australian states, with the highest concentration found in Western Australia, making Australia the world's largest producer of titanium and zirconium. However, there is a sad story to this. As a result of mining for the mineral sands, many ground vegetation may be lost. The salinity of the soil will increase, and both biodiversity and agricultural activity will be negatively impacted. There are also certain health concerns in mining for such sands, as some minerals such as monazite are uranium-rich and can cause radioactive exposure to the miners. Possible solutions to the problem can be monitoring the environment and the groundwater. It can be replanting the vegetation that were lost as a result of mining, monitoring the environment for any sign of radioactive pollution, using protective equipment while working on mines. Thank you very much. Have a great day.
Moving away from Australia into the Pacific, there is a mid-ocean ridge known as the East Pacific Rise. It is located on the boundary of the Pacific Plate and is created by the divergence of the Pacific Plate and the Cocos and Nazca Plate, and even the North American, the Rivera and the Antarctic Plate. Now let's have a closer look of what happens under the sea floor and uncover the reason of this formation. Here we have the underlying magma and the oceanic dense crust. Convection currents from the mantle push magma upwards towards the crust. Due to this force, the magma seeps through the cracks caused by the pressure and separates the plates and forms this boundary. As the magma flows, the cool temperature of the sea solidifies the magma, forming this ridge. Hydrothermal vents, also known as black smokers, named after the production of this black smoke, release mainly hydrogen sulfide, metals, and due to this combusting reaction, carbon dioxide. The particles are then gravitated towards the seafloor, creating sediment.
Pelagic sediments. These are fine-grained deep-sea sediments found in the pelagic zone, also known as the open ocean. They are mostly biogenic ooze that is usually rich in foraminifera with 60% pelagic and neritic grains. They are also commonly red clay.
Pelagic sediments are composed of particles from four major sources: continental weathering, volcanic activity, small parts of oceanic organisms, and chemical precipitation. These particles settle slowly over thousands of years, eventually resting on the seafloor. These sediments are then classed into three groups based on their composition: abyssal clay, forming at extreme depth, calcareous oozes, and siliceous oozes depending on organisms above. Pelagic sediments move along with the oceanic plates they rest on, eventually building up in areas of subduction, leading to an unequal distribution of sediment depth across the ocean. Once a sufficient depth has been achieved, sediments begin to compact over time and turn into pelagite and chalk, which are then either uplifted, forming continental plates, subducted returning to the magma cycle, or transformed into marble.